Good afternoon. London in December 1952 was a city that disappeared. Not in war, not in disaster that announced itself with sound and flame, but in silence, as a thick yellow fog settled over the streets and swallowed everything it touched. Tonight, I am here with Rowan Hartsteele.
Good evening, Clara.
Streetlights dissolved into the murk. Buses stopped where they stood. People put their hands on walls and felt their way forward one step at a time, unable to see the pavement beneath their feet. Tonight, we turn to one of the most consequential environmental disasters in British history, an event that killed thousands in silence and forced a society to confront what it had been breathing. The question tonight is not only what happened to London in the winter of 1952, but why no one saw it coming, and what it took to ensure it would not happen again.
For 5 days beginning on December the 5th, a mass of toxic air settled over London and did not move. By the time it lifted on December the 9th, the true scale of what had happened was still not understood. The deaths had been quiet. The disaster had no name yet.
We are speaking about the Great Smog of London,
A toxic atmospheric event that is now estimated to have caused the deaths of between 4,000 and 12,000 people, with some analysis placing the ultimate toll even higher when delayed fatalities in the weeks and months that followed are included.
Then let us begin with what made it possible, the conditions that turned ordinary winter air into something lethal.
In the first days of December 1952, an unusual combination of meteorological conditions came together over London. The temperature had dropped sharply, and the air was cold enough that Londoners had been burning more coal than usual, both in their fireplaces at home and in the industrial facilities across the city and its surrounding areas. At the same time, the wind had completely stopped, and then a phenomenon called a temperature inversion took hold.
So a temperature inversion is what trapped the pollution.
Yes. Under normal atmospheric conditions, warm air rises from the surface, carrying pollutants upward and dispersing them into the upper atmosphere. A temperature inversion reverses this. A layer of warm air forms higher up, above a layer of cold air at ground level, and acts like a lid. The cold air and everything in it cannot rise. It is sealed at street level. Every chimney, every factory, every power station continued to pour emissions into an atmosphere that had nowhere to send them.
So London's own pollution was being recycled back into the city continuously.
Yes, and the city produced an enormous amount of it. In 1952, coal was still the dominant fuel for domestic heating across Britain. 1 million London households burned coal in their fireplaces. Power stations burned coal to generate electricity. Industry burned coal to run its processes. The coal burned in domestic fireplaces was often of low quality, producing more sulfur dioxide and particulate matter per unit of heat than higher-grade industrial fuel. The combination of millions of small domestic fires and major industrial sources created a continuous stream of pollutants with no escape.
So conditions were not unusual in isolation. They had simply combined in an unusually extreme way.
Yes, London had always had fog. The city had been famous for it since the Victorian era, when industrialization first gave the fog its yellowish, sulphurous character. The term pea souper had been in common use for generations, and Londoners had developed a cultural relationship with fog that treated it as a nuisance rather than a danger. What began forming over the city on the morning of December the 5th was different in degree, if not yet recognized as different in kind.
So at first it looked like what Londoners already knew.
Yes, but it thickened faster and more completely than anything the city had experienced. By the afternoon of December the 5th, visibility on some streets had fallen to a few meters. By evening, in the densest areas, people reported being unable to see their own hands held at arm's length in front of their faces. Traffic ground to a halt. Bus drivers could not see the roads ahead. Some left their vehicles where they stood. Passengers walked home, or tried to.
So the physical experience of moving through the city had become impossible.
Yes, people navigated by touch. They put their hands on walls and fences, moving forward one cautious step at a time. Others simply stopped, unwilling to move in any direction when they could not tell what lay ahead. Ambulances were called out but could not reach their destinations. In some cases, attendants walked ahead of the vehicles holding a torch at ground level to find the edge of the road.
So, the emergency services were as blinded as everyone else.
Yes. Animals at the Smithfield Cattle Show nearby began to struggle for breath. Several prize cattle were found to be in severe respiratory distress. Some did not recover. This was one of the earliest visible signs that the air itself was acutely toxic, and not simply opaque.
Though the suffering of the animals was an early signal of what was also beginning to happen to people.
Yes. But perhaps the most extraordinary image from those days was what happened inside the city's theaters and cinemas. The smog did not stop at doorways. It seeped through ventilation systems under doors through any gap in the building envelope. At Sadler's Wells, a production of La Traviata was interrupted when the smog became dense enough inside the auditorium that the audience could no longer see the stage. At cinemas across the city, the beam of the projector was visible as a solid shaft of particles. The screen appeared through a yellow haze. Performances continued because the management understood that the alternative, sending people into the street, was worse.
So, the city had inverted its own logic. Inside was becoming as dangerous as outside, but outside had become the greater danger.
Yes, and through all of this the atmosphere thickened rather than thinning. The smog persisted for 5 days. The temperature inversion held. There was no wind. London continued to burn coal, because London was cold, and no one understood yet that the heat being generated was also generating the means of destruction. The chemistry of what was happening was understood by atmospheric scientists, though not by the general public or by most officials.
So, what was actually in the air?
Yes, the principal chemical threat was sulfur dioxide, a colorless gas produced when coal containing sulfur is burned. In the presence of water droplets which were abundant in the fog, sulfur dioxide undergoes chemical reactions that convert it into sulfuric acid. Londoners in those 5 days were breathing air that contained microscopic droplets of sulfuric acid, along with enormous concentrations of fine particulate matter, carbon particles and other combustion products that penetrated deep into the lungs.
So the fog was not merely fog, it was an aerosol of acidic particles.
Yes, and the human respiratory system, for all its remarkable capacity, is not designed to cope with that. The particulate matter lodged in the bronchial passages and the deep lung tissue, triggering inflammation, and making breathing progressively more difficult. For people who were already vulnerable, those with asthma, chronic bronchitis, heart disease, or weakened lung function, the impact was acute. The elderly were particularly at risk. London in 1952 had a high prevalence of chronic respiratory disease, a legacy of decades of industrial air pollution and heavy tobacco use. And the smog found those compromised systems with devastating efficiency.
So the smog was most lethal to those who were already most fragile.
Yes, and the deaths began accumulating within the first 24 hours, though this was not yet visible as a pattern. Hospitals in the city began receiving increased numbers of patients with respiratory distress. Doctors were treating what appeared to be a wave of bronchitis and pneumonia cases. The connection between the fog and the medical emergency was not formally recognized in those first days. Fog was familiar. People associated it with discomfort and inconvenience, not with acute medical crisis.
So the normalization of pollution worked against the recognition of danger.
Yes, London had been accustomed to bad air for so long that the threshold for alarm had been raised to an extraordinary level. Undertakers across the city began to run short of coffins. Florists ran short of flowers. Coroners were overwhelmed. But even this accumulation of evidence took time to be interpreted as what it was: a mass casualty event. The death rate in London during the smog and in the weeks immediately following was approximately 4 times the seasonal average. The mortality statistics, when they were eventually compiled, were unambiguous, but they were compiled after the event.
So the disaster was happening in plain sight, or rather in no sight at all, and the systems that should have responded were operating on the assumption that this was a weather event rather than a public health emergency.
Yes, and the government's response in those 5 days was essentially to wait for the weather to change. When the smog finally lifted on December the 9th, carried away by a shift in wind patterns, official statements attributed the unusual mortality figures to an influenza outbreak. This interpretation was convenient. It did not require any acknowledgement that the government's failure to regulate coal use or industrial emissions had contributed to the deaths of thousands of its citizens.
So the initial official response was not to investigate the cause, but to attribute the deaths elsewhere.
Yes, and this was not a fringe position. It represented the instinctive response of a government and an industrial establishment that had spent decades treating air pollution as an inevitable cost of economic life. Coal was not merely a fuel in Britain in 1952. It was the foundation of the nation's energy system, its export economy, and the employment of hundreds of thousands of workers. Any admission that coal burning in domestic fireplaces was responsible for thousands of deaths would carry implications that the government of Winston Churchill was not immediately prepared to accept.
So the political economy of coal shaped how the disaster was understood and described.
Yes, but the evidence was not containable. Researchers, public health officials, and eventually journalists produced analyses that made the connection between the smog and the excess deaths undeniable. The pressure built over the following years. Parliamentary questions were asked, scientific reports were commissioned and eventually published, and in 1956, 4 years after the smog, the British Parliament passed the Clean Air Act.
So the legislative response came, but it required years of pressure to produce it.
Yes, the Clean Air Act of 1956 was a genuinely significant piece of legislation. It created smoke control areas in which only smokeless fuels could be burned in domestic fireplaces. It gave local authorities the power to enforce these rules. It established a framework for regulating industrial emissions that had not previously existed in anything like that form. The shift away from raw coal towards smokeless alternatives, gas, and eventually electricity for domestic heating began in earnest. The character of London's air changed measurably over the following decade.
So the Great Smog produced a regulatory framework that would become a model for environmental legislation.
Yes, Britain's Clean Air Act influenced environmental legislation in other countries, and the principles it embodied, that air quality is a public health matter requiring government regulation, became foundational to modern environmental policy worldwide. The Great Smog is now recognized as one of the formative events in the history of environmental awareness. A turning point at which the assumption that pollution was simply a necessary condition of industrial life began to be replaced by the understanding that clean air was a right worth protecting.
Before we close tonight, let us take a brief pause and welcome Margaret Evernight. Margaret, for those who want to understand the Great Smog and its lasting consequences in greater depth, where would you invite them to begin?
Thank you, Clara. In this case, the most direct path is also the most important one. I would suggest beginning with The Big Smoke by Peter Brimblecombe.
So this focuses specifically on the Great Smog and its context.
It is a detailed study of the Great Smog of London, exploring its causes, consequences, and its lasting impact on environmental policy. Brimblecombe places the event within a much longer history of London's air pollution, which gives the smog a context that makes its causes feel not only understandable, but almost inevitable, given what had been allowed to develop over generations.
Is it accessible to a reader who is coming to environmental history for the first time?
It is written with both scholarly rigor and genuine accessibility. Brimblecombe handles the scientific material with enough clarity that it does not require a specialist background, while the historical narrative holds the reader's attention throughout.
So reading it gives you the science, the history, and the policy together.
Precisely. And understanding all three is what allows the Great Smog to be more than a single dramatic episode, but a turning point that changed how societies think about the air they breathe.
Thank you, Margaret. That is a thoughtful place to pause tonight.
Thank you, Clara. It was a pleasure.
The legacy of the Great Smog operates on several levels, and they are worth tracing carefully. At the most immediate level, the Clean Air Act of 1956 produced measurable improvements in London's air quality within a decade. A follow-up Clean Air Act in 1968 extended the framework further. By the 1970s, London's famous fogs had largely disappeared, not because the weather had changed, but because the pollution that had given them their toxic character had been substantially reduced.
So the atmospheric character of the city was genuinely transformed by legislative action.
Yes. And at the broader level, the event became a founding reference point in the development of modern environmental science and policy. The scientific work done in the years after the smog to understand what had happened, to measure the pollutants, to trace the health consequences, and to establish causal links between air quality and mortality, became Air Quality and Mortality, methodological templates for subsequent environmental research. The idea that a government has an obligation to ensure that its citizens can breathe clean air, which now seems self-evident, was not self-evident in Britain in 1952.
So the smog helped establish a principle that had not previously been stated as a matter of public right.
Yes, and this raises the deeper question the story leaves with us. How many people accepted, for how many decades, an environment that was slowly harming them, because the harm was gradual, distributed, and invisible, and because the structures that produced the harm were so deeply embedded in the economy and the culture that questioning them seemed unrealistic. The Great Smog made the invisible visible, briefly and catastrophically. It compressed into 5 days of acute crisis what had been happening slowly for decades.
So it was the acceleration of a harm that had been present all along.
Yes, and this is why the Great Smog remains a story that extends well beyond its own moment. Today, air quality remains one of the most significant public health challenges in the world. The World Health Organization estimates that air pollution contributes to millions of premature deaths each year globally. In many cities across Asia, Africa, and South America, the conditions that produced London's crisis in 1952, rapid industrialization, dense population, inadequate regulation, normalized pollution, are present in various degrees today.
So the lesson London learned in 1952 is still being learned elsewhere.
Yes, and the difficulty is always the same. The harm is often invisible, the cause is always embedded in things people depend on, and the cost of acting is felt immediately while the benefit of acting accumulates slowly. What December 1952 demonstrated is that sometimes the harm becomes visible all at once, and that when it does, the window for action can close as quickly as it opens. The Great Smog revealed that invisible threats can be as deadly as any visible disaster, and some disasters make no sound but change everything.
Thank you for staying with us tonight, and thank you, Rowan, for guiding us through the fog, the silence, and the long reckoning that followed a disaster no one could see clearly until it was already over.
London breathed its own industry for over a century before the air fought back. What changed it was not only science or politics, it was the willingness finally to see what had always been there.
If this conversation stayed with you, you are welcome to like, comment, and subscribe. You will find other episodes here where history, ideas, and power are approached slowly. Until next time, stay with us.